Hello student, myself Sushant Pal. I'm an assistant professor in the Department of Pharmaceutical Technology, JS University. So today we are going to discuss about our experiment number 4, and that is the effect of concentration on the rate of evaporation for the BPharm third semester student, and the subject is pharmaceutical engineering and the subject code is BPT 394. So let's start. So our objective of the experiment is to study the effect of concentration on the rate of evaporation. So at first we have to know what is evaporation. So evaporation, it can be defined as a process by which the liquid water that can goes directly to their vaporization state due to the increase in the temperature. So it is very obvious, if we increase the temperature, then we will get the higher rate of evaporation. Now the evaporator, those are the equipments, and that equipment can be used for the evaporation purpose. We can say them the evaporator. Now the evaporation is generally it is an unit process by which we can remove the water, and the water that will goes directly into their vaporization state due to sudden increase in the temperature. And the main objective of the evaporation is to get a concentrated product by vaporizing the volatile liquid. And the evaporators that can be generally, they are the equipments, they can be used to carry out the evaporation process, and the evaporation that can be conducted by the non-volatile solute and the volatile solvent. So the solvent should be volatile in nature, and the volatile solvent, so what do you mean by the volatile solvent? So the volatile solvents are those, they can be vaporized at very normal temperature due to their boiling point is very less, so that they can be vaporized in normal room temperature. Okay, so solvent should be volatile in nature, but the solute product, they should be non-volatile in nature. Now the rate of the evaporation that can be controlled by the rate of the heat transfer. So when the heat is applied in the solution, so the movement of the molecules that will increases, and the molecules that is present in the surface overcome the surface tension and of the liquid, the liquid and the evaporate. So the solvent, the solute molecule, they will the solvent molecule, they will be vaporized from their surface. Okay, so we can say the evaporation process is a surface phenomenon. Now the evaporation will differ from the other heat process like the distillation, just because of in distillation the vaporization will take place at the boiling point. Okay, now while in the evaporation the vaporization will take place below their boiling point. So in this session we will discuss further about the, or we will differentiate the evaporation and the other heat processes later. So the applications, now the applications of the evaporation in the pharmaceutical industry or the various chemical industries. So the evaporation, they can be generally used in the pharmaceutical industries and the chemical industries for the manufacturing of the bulk drug, and the evaporation can be used in the manufacture of the galenical product, which is the extraction product. And the evaporation, they can be used in the manufacture in the biological products such as the insulin. Now the evaporation, they can be used for the preparation of the blood products such as the blood plasma or the serum. So these are the wide area. So there we can use the evaporation to make the concentrated product. We can use the evaporation to make the blood product. We can use the evaporation to prepare the insulin. So these are the sectors where the evaporation can be widely used. Now the main objective of the process is to get the concentrated product. Now, the next objective of the evaporation process is to remove the water from the aqueous solution. And the third one is to evaporate the sea water for the developing the drinking water. And the fourth one is to get the solid free water, which can be used in the boilers for the chemical process. So now I'm going to discuss about the factors. So there are the various factors, they can affect or they can influence the rate of the evaporation. So the primary factor is the temperature, as the relationship between the temperature and the rate of the evaporation is directly proportional. So if we increase the temperature, then the rate we will get the higher rate of evaporation. So the evaporation rate is directly related to the temperature. As the temperature increases, the rate of the evaporation is also increases. Now because the temperature is rising, now what will happen? So the water molecule will begin to move faster, as the kinetic energy that will be acquired by the molecules, and they will escape from the surface to the vaporization state. Now the heat will be needed to provide the latent heat of vaporization, and in general the rate of evaporation, they can be controlled by the heat transfer rate. Now the rate of the heat transfer, that will depends on the temperature gradient. Now the next factor is the surface area that will be occupied by the liquid. So if we increase the surface area, then the rate of the evaporation will be increased. Okay, so the rate of the evaporation is directly proportional to the surface area of the vessel that will be exposed to the evaporation, or the evaporator. So if we have the larger the one evaporator which is having the larger surface area, then we will get the maximum rate of evaporation for that particular equipment. So surface area, so if we increase the surface area, then we will get the higher rate of evaporation, so we will get the more concentrated product in very less time. Now the third one is the agitation. So agitation is very necessary for the evaporation, so that we can able to remove the thin film that is formed on their surface, so that the liquid will goes directly into their vaporization state by when we apply the heat. If we remove that thin film that is formed on the surface after spending some time, then we will get the maximum rate of evaporation. So the agitation, by the agitation we can remove that film from the surface. Okay, so that we can increase the rate of evaporation by the agitation or by the stirring. Now the next factor, which is the vapor pressure, and the liquid which is having the lower boiling point, that will evaporate quickly due to their vapor pressure will be higher. So now the next factor is the type of the product required. So the selection of the method or and the apparatus that to be used for the evaporation, that will depends on the type of the product required. And just I'm giving one example, that is the open pan that will be produced the liquid or the dry concentrate, while the film evaporator will yield the liquid concentrate, that you have already studied in the theory part. Now the density, the as the density increases, the rate of the evaporation will be decreases. Now the next factor is the time of the evaporation. So it is very important parameter. So the time and the temperature, that these two parameters, they are correlate with each other. Okay, so the exposure to a relatively high temperature for a short time, that may be less destructive of the active ingredient than a lower temperature with the exposure for the longer period. Okay, so the film evaporation that will have, or they in the film evaporator generally we can use a fairly high temperature, but the exposure time will be very short, so that the heat labile substance we can use, or we can make more concentrated product by taking the heat labile substances. Okay, now the next factor is the economical factor, and when the selecting the method and the apparatus, the economical factor are very important. So the evaporator are designed to give the maximum heat transfer to the liquid. So another one equipment that you have studied earlier in your syllabus, from the multiple effect evaporator. So in that particular equipment, the vapor that is formed inside of the first evaporator, that will cause a heating to the product that will be in the second evaporator. So you will get the multiple effect, and by this approach you can able to reduce the cost of that entire process that will require to complete the entire process, so you can reduce the cost. So these are the economical factor. So economical factor, to maintain this segment or to maintain this parameter, you need to choose the evaporator which will give the maximum effect. Now the next one is the moisture content, which is the some drug that will constitute constituents that will decompose more rapidly in the presence of the moisture, and it is especially at the raised temperature. Hence the evaporation should be carried out at a low control temperature. So these are the parameters, or these are the factors that can influence the rate of the evaporation. So in this experiment, we will see that how the concentration of a product that can affect the rate of evaporation. Okay. Now I'm going to discuss about the differentiation between, or we are going to discuss the difference between the evaporation and the other heat processes, like the what are the different heat processes. Like the other heat processes, like the boiling, distillation, drying. So these are the heat processes, and the difference between these three with the evaporation. So evaporation is a process in which a substance that will changes its the state from the liquid state to the gaseous state without boiling. Now what will happen in case of boiling? So the boiling process in which a substance will changes its state from the liquid state to the gaseous state. Now the next one is the drying, is typically the word they, or they can be used to describe the removal of water from a substance. And the next one is the distillation, that will include the transforming liquid to the gas by the heating and condensing the liquid. Now this is all about the theory part, and let's see what are the requirements for the experiment. So we will need a beaker, 50 ml of glycerin, and the beaker that will contain 100 ml of purified water, and the beaker that will be in the beaker 250 ml of sodium chloride solution. We will need a water bath which will act as a heat, or they can be act as a heating source. And we will need a balance, weighing balance, and the weight box, the measuring scale, and the measuring cylinder. So these are the requirements for the experiment. Now the experimental method. So at first we need to prepare different concentrated solution in it by taking the sodium chloride. So we will make 2, 4, 6, and 8% W by V, that means the weight by volume solution of sodium chloride, and we need to prepare it by dissolving 1 gram, 2 gram, 3 gram, or 4 gram of NaCl in 100 ml of water in a beaker. Now the beaker that will contain the NaCl solution, they are weight, or we need to take their weight. Okay, and we need to mention that weight as the W3 gram. Then, or we can record it in our notebook, and also there is an observation table, so we can also mention their weight in that table. Now all the beakers, they will be heated in a water bath at the constant temperature, that is 70 degrees Celsius, for 30 minutes. Okay, so all the beakers were weighed again after heating, and we can mention their weight as W6 gram. So the weights are located in column 5, that is table number 3, and that is the observation table. And the difference between their weights, that will be determined, and the difference will reflect the amount of the water evaporated during the 30 minutes. So the rate of the evaporation, then we can calculate the rate of the evaporation, and also we can plot a graph that will taking the rate of the evaporation on in y-axis, and the concentration of the sodium chloride in x-axis. I again repeat the experimental method. So we need to prepare the sodium chloride solution, different concentrated sodium chloride solution, by dissolving different number or different gram of sodium chloride in 100 ml of water, and we need to keep that solution in a beaker, separate beaker. Okay, now we're going to take their weight, or we're going to by using a weighing balance. So after getting their weight, we need to write it in our observation table. Now all the beakers will we need to heat by using a water bath at the constant temperature, that is 70 degrees Celsius, for 30 minutes. So after spending 30 minutes, we need to take the weight of the beakers as the previous one, and we need to mark that mark their weight as W6 gram, or also we can write their weight in that same observation table as the W6. So now the difference between the weight, that will be determined after the experiment. So that difference will reflect the amount of the water that is evaporated during 30 minutes. So the rate of the evaporation, that can be calculated as per the observations, and a graph that should be plotted by taking the rate of the evaporation on y-axis and the concentration in x-axis. So this is your observation table, and the observation table has the first column is a serial number, and the second one is the concentration of the sodium chloride solution. And as you can see, there are the four concentrations, like the 2%, 4%, 6%, and the 8%. So their initial weight of the beaker, that is the W4 gram, and after 30 minutes of evaporation, we need to, or we can make their weight as, or we can write their weight as a W5 gram, and and next is a difference in their weight, that is the W4 minus W5, or you can say the initial weight and the final weight, and the time of heating minute, which is the 30 minutes, and the rate of the evaporation, that is the gram per minute. So this is all about the observations table, and you can calculate after getting the results. Now the conclusion: with the increase in the concentration of the sodium chloride solution, the rate of the evaporation is generally it will be decreased, so that the concentration, if the proportion of the sodium chloride is very high in a solution, then the evaporation rate will be lower. This is a theoretical assumption, but after performing the experiment, you can say, or you will get the result, the same results as you have studied in the theory. Okay, so these are the references, and these are some important questions, like the evaporation. The first question is define the term evaporation, and the evaporation is a process by which you can define them as an unit process by which you can able to remove the water, and by applying heat, or you can make more concentrated product. So for the evaporation purpose, the solvent should be volatile in nature, and the solute molecule should be non-volatile in nature. Now the next one is what are the application of the evaporation in the pharmaceutical industry. So we have studied that the evaporation process can be widely used in the preparation of the bulk drugs. So evaporation process can be widely used in the insulin production, or they can be used to make more concentrated products. So these are the applications and where the evaporation can be done. Evaporation process can be done in the pharmaceutical industries. And the third one is what are the factors that can affect the evaporation rate. So the temperature is the primary factor, or if we increase, and the temperature is directly proportional to the rate of the evaporation. That means that if we increase the temperature, then we will increase the rate of the evaporation. And the second factor is the surface area of the evaporator. So higher the surface area of an evaporator, and you will get the maximum rate of evaporation. So we can say the surface area is directly proportional to the rate of the evaporation. Now the third parameter is the agitation. So the agitation is very necessary for to increase the rate of the evaporation, so that we can by the it means after the agitation we are able to remove the thin film that is formed on their surface. So after removal of that film from the surface of the product, you can able to increase the rate of the evaporation. Okay, now these are the factor, so on which or they can influence the rate of the evaporation. So these questions can be asked during your practical examinations. If you have any doubt regarding this experiment, feel free to ask. I'm ending my session. Thank you for being with me.